All right, looks like everybody's coming in to the session. So thank you again for joining us for the second part of our sessions for today. So welcome and thank you for joining the Irrigation Association's 2022 Agriculture Faculty Academy, sponsored by Rainbird and Seninger. I'm Noreen Rich and will be facilitating your session today. So before we dive into the session itself, which is fertigation and chemigation, application based on data, I'd like to take a quick moment to cover a few housekeeping items. Okay, so first of all, today's session is being recorded and we will share the recording with registrants post-event. So please keep an eye on your inbox. We'll likely send it next week after we've done some post-production trimming to it. Secondly, we have muted everyone by default, so we won't be disrupted by any latecomers. So please keep your microphone muted throughout the presentation unless you have a question for our speaker, as this will help minimize any background noise during the presentation. Third, during the presentation, if you have questions though, you can ask them verbally by taking yourself off mute. There's also a raise hand feature that you can use and we'll keep an eye on that and call you out. Or you can also use the chat box, which we will be monitoring throughout the session. So there's that. And then finally, don't be too shy. We are trying to encourage some interactivity. So again, feel free to have your video on and to use that verbal kind of question asking route or the chat box. We just want to make sure we're getting all the questions answered that we possibly can. So I'm going to stop sharing my screen. And so without further ado, we're going to welcome Jake LaRue. He's an independent irrigation consultant who is going to take over the presentation and share his screen now. So go ahead, Jake. Yep, and we can see it presentation style, so it looks like you're good to go.
Okay, and I apologize to all of you for the last go around because it was a little rough and rocky, but hopefully it'll go better this time. Appreciate everybody's patience on that. So we're ready to go, Noreen?
Yep, we can hear you, see you, and we got your slides up here now, so we're good to go.
Okay. Again, I just want to reinforce there will be mention of brand and trade names and pictures of products. It's not an endorsement. It's just something to help us to have pictures to talk about. I kind of like pictures myself, so what can I say? Oops, went the wrong way. Again, I cannot emphasize enough, understand what is going on from a regulation, permitting, and licensing requirements. Critical. Product label, got to read it. We went through that the last time for the ambush product. I think you saw how important that information is. We're going to go more into posting and re-entry requirements and a little bit more on reporting in this time. So please be sure that you pay attention to what all's going on, because it's really critical and we certainly don't want anybody to get in trouble. So for this session, we're going to discuss a little bit about the steps for actual implementation, initial planning, the application process itself, post-application. I'm amazed how often people don't even want to talk about post-application for some reason. And then we'll end up with a questions and comments at the end if anybody has anything they want to talk about at the end. Okay, so when do I start my initial planning for the crop season? Well, guess what? To do it right, you better be starting right as you're harvesting. So getting ready for 2023 crop starts with 2022 harvest. Hopefully there are yield maps being collected on the combines and good yield maps. If a grower is not having a good yield map, I encourage them to write notes down on variations in the field. It's amazing what you can see from the cab of the combine and get a feel for what's happening in the field. So some notes can make a lot of difference. We want to compare what the fertigation and chemigation plan was and what we were planning for to the actual yield to help us decide what we do next year. Hopefully that all makes some sense for you. The next thing is start thinking about the crop. And I know that can change whether you're rotating crops. If you're raising potatoes, you're probably not going to go back with potatoes again. You're going to rotate to something else. Maybe in continuous corn, but given the price of nitrogen fertilizers right now, some people may do a little more soybeans or rotate to something else. But think about it. Think about it early. The other thing to remember is, do you need to renew your applicator's license or any of your permitting? Don't let that slide, but make sure that you get it done ahead of time. It's what we always encourage the growers to do. And start thinking about adjustments to your nutrient and plant protection plan. What changes you want to make for the next crop year. Continuing on with some planning stuff, we should have a soil test, or a fairly recent one. It isn't uncommon. I ran into a grower late last summer, and he was complaining, and I said, well, when was your last soil test? And he looked at me like, soil test? What's a soil test? Which is unfortunate. If we really want to be cost effective and efficient, and given the prices right now, we really need to be focused on being efficient. So soil test, well worth the money, and collect the soil test, the soils correctly. And I'm not going to go into the detail, but there's definitely rights and wrongs in that. And just keep that in mind. Your extension service would be able to give you some good information. Another one, and it doesn't apply to everybody by any means, but there are areas in the country where the irrigation water contains a fair amount of nitrate nitrogen. So a water chemistry test is important. We talked last session about it being important to understand potential for corrosion. This time what we're looking at is what kind of level of nitrate nitrogen might you have. It's not the most common thing, but still, good grief, if I'm applying 12 inches a year and I've got 15 parts per million of nitrate and nitrogen, that's equivalent to 41 pounds of nitrogen per acre. So why waste money on that? Let's utilize what we've got and be as absolutely as efficient as possible. Then as you're doing your initial planning, start thinking about, okay, what's my proposed fertigation and chemigation plan? How am I going to blend that potentially with some pre-applied anhydrous ammonia pre-plant? It's going to be a little less expensive, and it certainly can help us. So don't necessarily try to do everything with fertigation and chemigation, but we want to apply what makes the most sense in the area that it makes the most sense.
We have a quick question too, related to the soil test. So it's, do you recommend a soil sample per hectare? I'm sorry, I don't know the measurements, but.
I'd approach it a little differently. And if I'm doing a field, first thing I'd want to start with is a soils map so I know what my soils are. If I'm not familiar with the particular field, if I'm just starting to rent it, where are my silt loams at? Where are my clays at? Whatever. And then normally I'm lazy. I won't take more than 10, 15 samples in a particular area of the field, a particular soil type, because I will feel that'll give me a pretty good indication. I'm sure many of you out there in the group would have advised differently, but there's certain realities, and I'm lazy, like I say.
Thanks, Jake.
Okay, determining need. We're looking at our initial fertigation plan. Is it still basically correct? Is our yield projection on track? Because remember, we started all of this right as we were harvesting last year. Could change depending on the crop. What material? Generally for fertigation, it's going to be 28 or 32% UAN. And what's the timing? We looked at this picture the last time where we have multiple steps of applications. The first application down here could be an anhydrous ammonia application. And then we would have 1, 2, 3 fertigation applications. A lot of times probably would do more than that depending on the crop and the time frame. But one way or the other, we should have an idea of what our plan is, what our costs we're estimating are, so we can make changes as we understand what our income situation may be on the field. What can we justify really spending and putting into it? Now then, after we get to the point where we're starting to go with our field, we need to be looking at how do we determine what's happening. Number one thing is soil moisture. Now I can collect soil moisture data as I'm walking through the field with my trusty soil probe, or I can have probes installed. We can have other in-field hardware. The far right side there is actually a weather station. And in the middle slide or middle picture is a picture of hardware mounted on a center pivot collecting data for the particular field. So there's lots of different hardware potentially available through your irrigation dealer, through your irrigation manufacturer, your pivot supplier. Everybody's working on different solutions and how to do things better and make it readily available through our cell phones. Still can't beat actually getting out in the field and walking. Not my favorite subject on a nice hot day, but it's definitely got reasons to do it. Looking at my pivot, my sprinklers all working. Looking at the crop, just scanning around, a lot that I can see. And this table, actually it's from Pioneer Seed, looking at the impact of uneven emergence. And some places this year are having some challenges. And you can see that they're run the potential of being really good. We start not being so good, clear down to the bottom. I mean, we have a potential loss of stand of up to 20%. Now, if I've lost 10 to 20% of my yield or of my stand, how is that going to impact my yield? And do I still want to be applying the same amount of fertilizer and other products? So it's something to think about, and it really starts early on in the season. We can't wait until way late in the ball game. Now, this particular slide has 3 different images, all taken from the same satellite on the same day. We've got NDVI on the far left, infrared in the middle, and a color print to the right. And even though it's a color print, not seeing a lot of difference in colors in that field. And you certainly can see more detail shown with the NDVI and the infrared, which is part of the reason why they're utilized. We want to try to understand and see as much as we possibly can to understand what's happening in the field and potentially what we can do about it. Now, just in case you're not following, on the far left side, which would be to the west, there's actually the farmstead. So this pivot only can make a part circle. It cannot go completely around, which has management challenges in itself, because that means if I go around and I'm on the other side, as I start back, that's my wettest all the way around to my driest. So there's some different management things that come into play, but it gives you a sense of the information that can be available to you. There's going to be 2 sets of slides here. This first one is satellite data. It's infrared. taken on June 16th and June 30th. You can see the crop is not looking wonderful. On June 16th, I've got a little bit of improvement on the 30th. We're trying to get some more water onto it. A grower was a little slow getting started with his water because he was busy doing other things. I can't blame him. I understand. But it's something that we just need to be aware of and make sure that we approach it correctly. And you can actually see on the 16th of June, this wedge here, that's actually the pivot running. And it's sprinkling, and it happens to be moving clockwise. You can kind of see an outline of the drive or of the spans right down through there. Anyway, so this was our challenge to try to get this improved. The area on the far right side or to the east never was going to fill in correctly. There was a pretty severe windstorm and enough sandy soils in this field that it literally cut some of the plants off and they did not come back. So if we look at July 23rd, hey, we're making progress, looking a whole lot better. And we get over to August 6th, you can see that progress has continued and the crop really is filling in pretty decently. Looks like we may be on track for a decent harvest, but there's still differences. And we were actually using speed control in this particular field and varying the application depths. There's this area down here, which all along has been better. We were putting a little less water in it. Also was a slightly heavier soil. We put more water on, slowed the pivot down across into here to get to really try to keep the crop pepped up and to evened out. So hopefully that makes a little bit of sense. Here's another example. It's satellite imagery and it's NDVI. And this field is a mess. I'm sorry. The red, there is no crop at all in there. You can see where the wheel tracks are cutting across. This pivot actually had VRI zone control on it, had 11 zones. It's a little more than a 1/4 mile machine. If I remember, I'm thinking it was about a 1,500-foot machine. And these areas, these crooked areas here, they basically don't have crop because they have standing water early in the season. And they got their grassed areas for it to cross. But definitely a challenge. Certainly the variable rate zone control lend itself to putting water in the right places and not wasting the UAN 32 because we're putting it where the active growing crop is as much as possible. We did some tinkering with prescriptions, but we got to where it was pretty good. We never applied any chemigation on this field. It was all just nutrient management and water. Here's another example on pivot. You can see June 6th didn't look so good. June 11th, oh, that's not looking so good. As we go along, we see that gradually it's improving and we were getting a crop, and by July 9th, good grief, hard to believe that it's the same field, but it is. And part of the key on this is we got pretty uniform soils on it. So there were some distinct advantages that we didn't have to overcome. This particular customer did not plant the corners. This was corn, and he didn't plant the corners because of potential shortage of water. Put on a number of applications of urea ammonium nitrate, 28005, and the 5 represents sulfur. Here's another slide. What we're looking at, and we saw this before, but when we're determining need and we're thinking about it, certainly from a product standpoint in the US, typically it's going to be the liquids. Internationally, it's not uncommon to use urea, dry fertilize, It's mixed gradually with water and agitated and injected as an in suspension into the center pivot. Worked with a number of different people in different countries, and it can definitely be effective. So those are the products. When to apply really depends on our overall plan and how much we put down pre-plant, if any. So we want to start applying our fertilizer plan once the growing season is start, and we modify based on the crop development and yield estimates. And that's the beauty of satellite imagery, probably drone. Haven't had the opportunity to work with much drone data, where we can see the whole field and get a quick snapshot of what's going on. And with the more modern control panels on the pivots, there's a lot we can do with speed control to adjust as far as how much water, how much fertilizer we're putting down. I see somebody raised a hand.
Yes, Jacob, just a comment. I want to add to you and the audience. We are working with drone imagery to detect nitrogen deficiency. And we have a manuscript published in Precision Ag where we can detect the nitrogen early for corn at like V6, and we can adjust the applications for this. And I can share it with the audience, or I can share it with Serene, and she can send it to the group as well. But the main purpose for this paper is to detect nitrogen deficiency early for corn and for rice, and we can adjust and develop variable rate prescriptions based on drone imagery. The challenge is with drones, you have to, like here in Arkansas, it's kind of cloudy and it rains a lot. So satellite imagery, it's good when we have a clear sky, but this is not the case for every place here in Arkansas. But other places like in California and the West, if it's like clear most of the year, so satellite will be very efficient in terms of drone operations and even obtain high resolution imagery for nitrogen applications. So I will send this paper for after the presentation.
Great. Yeah, send it my way, Ahmed, and I'll share it with the group.
Sure. Thank you, Noreen.
Thank you. Those are good comments, and certainly makes good sense. Our plan for our when to apply is going to depend really on how the crop is developing and our yield estimate. That's one of the beauties of applying with the center pivot, is we have numerous opportunities to make adjustments during the season. The rate based on the plan, and we adjust according to the current crop. So we've always got a chance to make corrections and improvements in what we're doing. Hopefully that makes some sense to you all. Here's a type of a calculation, and it's really looking at the costs if we applied anhydrous ammonia 82% versus UAN 28, which is 28%. And we look at a target application of 200 pounds. The anhydrous would all be pre-plant. We're estimating, because of the loamy sand soil, potential loss of 15%. We're having some loss also with the fertigation application. Goes on down through the calculations, looking at the labor, the fuel costs, cost of the anhydrous ammonia, the cost of the 28005, all the way down to where we get to the bottom, including applications for multiple 28%. We see that the cost per acre comes out very, very close to the same. And obviously, the anhydrous itself is less expensive per pound of N than the liquid, but other costs are going to make some difference in that, and the potential loss to leaching or runoff. And we get into the season and it looks like the crop is not a 200 bushel crop or a 220 bushel crop, and maybe it's only 180. And with the anhydrous, we put all of that down and we're just not going to get the crop out of it. So it's really, to me, it's a combination of the two. Certainly anhydrous ammonia is a good source. And let's not put all of our eggs in either the anhydrous ammonia or the liquid nitrogen. The combination of them has a lot of advantages depending on your soil type. And of course, it depends on the farm operation. This spreadsheet's a whole lot more complicated, and I apologize. Don't expect you to look through it all, but it gives you an idea of what can be looked at, and it gets us down to the calculation, how many gallons per hour our injection pump needs to be doing. And in this case, we're saying that we're going to apply roughly 50 pounds per acre. We need 613 gallons of 28%. We're going to apply it in 52 hours, means that we're going to be applying about 12 gallons per hour, which would be where our pump is set. At the top there, you can see we can account for nitrogen credit from previous crops, from the soil test, and from the irrigation water, if there happens to be any, to help understand truly what's necessary. So there are many different spreadsheets out there. If you go on the internet, I know several different universities offer calculations. Probably be advantage to definitely using one from whatever state you're in if you wanted to. Okay, the application process. And actually this picture has a drone in it. I didn't realize it even had a drone picture until I was running through this morning. If we're chemigating, and generally, not always, but it's going to be insecticides and fungicides, it's going to be based on scouting to consider what's my possible products that I could use for whatever problem I identify. Is it corn borer? Is it blight? Is it who knows what? But we want to be able to collect the data so we can make an intelligent decision. So what do we apply? When do we apply it? With the chemigation, it's always when to apply becomes a lot more critical because timing is very important. So we want to identify the problem and get ready and set up to do it, and follow the label for what's recommended for our particular situation. Looking some more at chemigation, if we look at types of application, like for corn borer, for instance, aerial application, and these prices were calculated back in, I believe, March for another project I was working on. And at that time, aerial applicator that I was talking to, and I talked to a couple of different ones, they were talking $15 an acre. What it is today, I have no idea. It's probably higher, maybe quite a bit higher. With a ground rig at the same time, the co-op was quoting $21 per acre. And the estimate I made based on the chemigation system was $1.03 for labor and the equipment. So these numbers are not absolute by any means, and you really need to look at them for your particular area and yourself to determine, okay, what makes sense. The main thing is it's a definite difference in, you can see kind of a ratio to the chemigation. Both of the others are pretty expensive. I think somebody raised their hand again.
Yeah, I'm sorry, Jacob. So you mean for the chemigation with pivots, that's right?
Correct.
Okay. Thank you.
Excuse me. We had talked in the other session about the chemigation tank. And really, in most cases, it's probably going to be well worth the investment. There are cases where it may not be necessary, but given the volume that's usually being applied for most crops, for fungicides and insecticides, it probably makes sense. some of the potato products and the way they manage the potato diseases. They do use the larger tank because of the way they handle the product. But it's a matter of sitting down and considering what makes the most sense, what's going to make you as efficient as possible. And as we talked before, are we talking about a systemic or a contact product? Because that's going to make a difference in how we irrigate and how we handle the whole system. If we look at our steps more, when we actually get ready to do this, we need to be aware of where is our water usage headed. What's my current water use, either based on radio, newspaper. If I've got a weather station in the field, great. But we need to know, okay, what's my expected water use in the next week to 10 days? Confirm current soil moisture status to help us understand, okay, we got this much deficit in the field. We've got this much use coming up. The crop is growing rapidly. We need to understand how much we need to be putting on a weekly basis. Now, if we're just irrigating, life is pretty simple. But if we're fertigating, still should be okay with following whatever the irrigation schedule is looking like. But if we're chemigating, our plan may be calling for more moisture to be applied than is reasonable with whatever our product is. Like the ambush, for instance, it showed a 1/2 inch or less, and typically a 1/4 inch is probably the optimum. So it's something to be aware of. We need to be thinking what our water balance really looks like. We got to account for everything. Well, if you're in the desert, you probably are not going to deal with rain, but certainly we need to be considering the different ins and outs for our crop. Continuing on, we determine the irrigation depth. That's what we were just talking about. We talked about the depth can be what is normal with fertigation, with the irrigation, and then the chemigation, what our depth needs to be. And we've got the issue of we can only apply so much water with the chemigation, probably won't meet the plant needs. Then we've also got to deal with the waiting period. Remember, we posted the field and it said our re-entry time. Well, that's not just apply to people. It also applies to how long do we need to not irrigate so we wash the product off of the crop. Is there a waiting period? So we need to balance the chemigation needs with the irrigation needs. Which one is going to have the biggest impact on our yield and the future of the crop? Okay, got our equipment ready to go. We've got our injection pump set based on the calculations. We know how many hours to complete the circle. We know how many total gallons we want to apply. So we can set our injector pump in terms of gallons per hour. And that's really the critical factor. The dial won't necessarily read directly in terms of gallons per hour, may be close depending on the particular brand of pump that you're using. At the same time, it will be scaled, and there should be something that will tell you in the manual approximately what the scale refers to in gallons per hour. And I will always encourage people to run a test, figure out where you're actually at, so that you can determine, hey, this is where I need to be set to get this many gallons applied. So it's a learning process, and you just need to understand about the equipment and what it can do. We talked before about needing personal protection equipment. What this person is wearing may be overkill with the aspirator that's on there, but certainly You need eye protection. You need an apron in a lot of the chemigation products because they may attack the plastic. It just all depends. But your label on your product is going to recommend what you should have for your PPE, your personal protection equipment. So I'm going to fill my tank with the appropriate product. And is agitation necessary? With the 28 or 32% liquid, no, don't need to agitate. Internationally, if I'm using urea and I'm mixing with water, a lot of times I need to at least agitate in the beginning to get everything into suspension. I may not need to agitate during the whole irrigation cycle. It'll depend a lot on the water temperature and the water chemistry. But just be aware, probably need to agitate some. With chemigation products, they're probably going to need to agitate. You got to be careful about foaming, as we discussed before, and certainly air agitation can be an option. But you just need to be aware the label should be telling you about what is required and what is recommended for the particular crop. Continuing on, we determined the irrigation depth. Fertigating, like we said, that's okay. We could probably go with the same depth while we're fertigating. One thing you need to remember, it makes a whole big difference if I'm applying a 1/2 inch of water, the size of injector pump I need, because I'm going to get over the ground a lot faster, versus how many gallons per hour my pump needs to do if I'm irrigating and applying 1 inch. So when you're thinking about purchasing for fertigation, make sure the equipment makes sense over a range of irrigation depths. And certainly early season, you may only want to put down 1/2 inch or even less. And of course, you don't need as much fertilize, but the crop moisture or the soil moisture may not be to the point that there's a huge need for a significant depth. So we're going to start our irrigation pump. Want to look and see that our sprinklers are working as good as possible. We set our water depth to apply or our rotation speed, depending on the type of panel. And we're ready to start the pivot after we're up to our operating pressure. And for sure at the pivot point, you should have a note there or something that says, okay, at this pivot, I need to be operating at 32 PSI. If I'm lower than that, my uniformity starts going to pieces. If I'm higher, generally not a problem unless I don't have pressure regulators. But one way or the other, we really want to be at or near our correct operating pressure for the crop. So we open the valve on our chemigation tank, our fertigation tank, start our injector pump, and we doubly confirm how long it'll take to make the application for the pivot. And then we monitor the performance. Old days, I had to run back out there to see that everything was still running correctly. Now, it is so easy. I mean, I get a message on my cell phone that tells me how things are going, or if something stops, or if there's any kind of a problem. So there's a lot of advantages with the technology that's available today. And I encourage people to utilize it, because particularly when you're chemigating and even with fertigation, to know what is happening. Okay, we got our application on. Post-application. Yeah, you're not done just because the pivot finished its circle. Number one thing is, what's the level in my tank? Is it what I expected it to be? If it's a lot more left in the tank than expected, what's that mean? Well, it means I didn't get enough nitrogen on for fertigation. If I'm chemigating, I didn't get enough whatever the product on is. If the tank is dry, we may not know when it went dry. So what are we going to do? And it's really a matter of stopping and thinking, determine if it's just fertigation, probably can get by and wait for the next go around or maybe move up the next cycle. If it's chemigation, need to stop and think about what's the implications. I'm not going to say there's a magic bullet for this. I want to flush the pivot for 5 to 10 minutes for a 1/4 mile machine once the application is finished. And if I need to, I can rinse out my injection equipment as we go by. Okay. Oop. I think I see another hand raised.
Yep.
Yes, so for the flush out, so do you recommend to keep the pivot running or just stay on the same place to start the next irrigation while you are flushing out the system?
Great question. And I'm going to say it depends. Depends on my soil, depends on where I'm stopped. If it's a fairly sandy soil and I'm not going to have a lot of puddling, for 5 to 10 minutes, I'd probably just run in place. If I was concerned about it being a heavier soil and being pretty wet, then I might start to pivot up and run it a little bit during the flushing and then back it back up to my normal starting point. Like I say, there's not an easy cut or dried answer, I don't feel, and it depends on the particular operation. I've known growers that would always say do it one way or the other.
Thank you.
Re-entry, we talked briefly about this. If your product label calls for it, you need to be sure that you post them. And also if your local regulations do. On the sign, it's going to ask for what is the name of the product, what was the date of the application, and it'll ask, it says do not enter until. So it could be a 6-hour waiting period, 12, 24, whatever it is, needs to be posted on the sign so people understand what's happening. And I've included below this the Nebraska Administrative Code, which goes into a lot of the detail, and I'm not going to go through all the specific detail. You can look at it, look it up online for your particular state, what the code may be. So it's just kind of general information, with Nebraska being one particular example. Continuing on as far as what I'm doing post-application, record, write down what happened, or type in the computer, what happened, what you apply, when was it applied, what rate was applied, were there any problems that popped up? Keep track of that. You're probably going to need it at the end of the season, and whether you need it for reporting or not, you ought to be keeping track, because it's going to help you understand what happens going forward and maybe a change you need to make. Hopefully that makes sense. Continue monitoring the crop. Is it on track for the yield estimate that I'm using? If it looks like it's not, and my crop yield's not going to be as high, well, then I need to make an adjustment. Maybe not apply as soon for the next application and change how much is put on. So it's an ongoing process. It isn't a one-time deal. And in some ways, it'd be a whole lot easier just to say, well, I'm going to put on anhydrous pre-plant and call it good, not even mess with this other stuff. But from a sustainability standpoint, from an overall cost to the farm operation, there's definite pluses to fertigating, and you just need to be aware of what in the world's happening. End of season, what did my yield come in at? If I've got a yield map, look at how you applied and how the yields came out. Did it meet our expectations? And if not, why not? There's a whole bunch of different possibilities you can blame it on, and it could be a combination of them. But you need to think through that to prepare for the next season. Make some notes for the next season. And you've got your information for your regulatory reporting, which depends on the state what you'll need. But certainly you need to think through this in the fall. So we've touched on a bunch of different information. We've gone quite rapidly down through this. What's effective fertigation and chemigation, information for the practices, review of the licensing and regulatory process, the actual application process. You could easily come up with slightly different variations, but there's some basic things you need to do, such as determining need, doing calculations, and monitoring the need. Impact of conditions of the field and crop for overall is really what you're needing. So that kind of closes this portion out. And with that, I will turn it over to our coordinator there, Miss Noreen.
Yes. So thank you, Jake. So I'll keep an eye again on the chat box, or we've had a few people kind of raise their hand and just verbally interject. So I don't see any questions in the chat box at this moment. So I'll keep an eye on that. And then I'm going to kind of run through my kind of closing housekeeping. But before I do that, any other kind of closing thoughts, Jake? I know from a committee perspective, when we were trying to determine the topics and subjects for this year's Faculty Academy, this came up as kind of a new one that a lot of educators don't have a lot of information on. So we're hoping this is starting to establish a baseline of that. And I don't know from an industry perspective if you feel that this is a relatively new topic as well.
It's not a new topic, but it's certainly a topic that's getting a lot more attention right now. Not just from one manufacturer, but a couple different manufacturers. We're realizing the need to be more efficient, to really help the growers. We have a lot more requests, both domestically and internationally, for information. And so we want to make sure that they're having the dealer network has the best information possible. So I anticipate in the next year, there's going to be a lot more information coming out relating to more specifics. And I apologize, we went through really quick, but certainly stuff to consider.
Great. I see, looks like Ahmed, you have another question. So if you want to just chime in.
Yeah, so regarding the variable rate applications, so do you work with lots of variable rate applications and pivots with fertilizers, or this is only for irrigation, and assuming that the irrigation is going to do the same thing for the fertilizers?
I've worked with it both. We started out working with it for the irrigation. And then obviously, because we were working with fields that the soils, we picked the hard ones. We didn't pick the easy ones. And so we started doing it with fertigation. I have never used variable rate for chemigation. We have had some discussions. I've talked with a couple dealers that have customers interested, but nothing specifically has been done. And overlooked frequently is the variable rate with speed control, which is not true variable rate, but it is and it isn't. And it's certainly something, any of the more modern panels give you the capability to do it. And it has some distinct advantages. It's not perfect, but it saves the investment into the all of the valves and hardware that goes along with the true variable rate zone control or individual sprinkler control.
Sounds good. Thank you.
Great. Okay, well, I don't see any other questions. I'll give it one last look through as I kind of close this out. But just to kind of quickly, again, if you were with us last time, I did mention that the Irrigation E3 program is now accepting applications. So this is an opportunity for students and faculty to join the industry in Vegas in December at the 2022 Irrigation Show and Education Week. So applications are open now and they will go through September. It's a great opportunity, great learning experience for everybody involved. So please visit the website for additional information on that and or look in your inbox because we'll be promoting it heavily a little bit later in the summer. And then also just make sure you visit the IA store on the website too. As mentioned, there are about 20 different topics from teaching kits and student workbooks that you can use to build some curriculum. And you do get special pricing as an academia. So again, some good resources there available for you. So I think that is it. So let me just take one more little look at the chat. and see if anything else came in, but thank you again, Jake, so much. Go ahead.
May I ask a question?
Mhm.
Is Steve Melvin still on?
Let's see.
I'd seen him before, but I see him, looks like he's ducked out. Okay, that's fine. I just was going to see if he had any particular comments because I know he's had a lot of experience with this.
Yeah, so, and I know he chimed in at the last session too. So, but we did record this session, so we will share it with everybody probably early next week once we have it available. If you are attending tomorrow's session, that begins at 12 p.m. Eastern time, and that is IoT, Edge Computing and Deep Learning in Agriculture. Again, we will be sending out those links for tomorrow's sessions early in the morning. So be sure to use the correct links when you access Zoom tomorrow. And I think that is it. So thank you so much, Jake, for a great presentation. And thank you again to everybody who joined us. And a final thank you to our sponsors, Rainbird and Seninger. So everybody have a great afternoon.
Thank you all.